Here we want to graph using transformations. We have the exponential function 3 to the x plus 1 minus 1. Before we start just jumping into graphing that function, let's first graph the function 3 to the x. Let's just start off by understanding what does 3 to the x look like, and then that will allow us to easily graph the shifting of x plus 1 in the exponent and then minus 1. What happens there? What does that imply? So let's first graph 3 to the x. So 3 to the x is an exponential function. That means it's going to look something like this. It's going to travel down this... it's going to look something like this. It's going to travel down this asymptote of the x-axis. And then what we really want to make sure we understand is what happens at 0, 1, 2, and so on. So x equal to 0, that's going to be 3 to the 0. Anything to the 0 is 1. So at x equal to 0, we cross through 1. And then 3 to the first is 3. So when x is equal to 1, we get to 3. And then when x is equal to 2, that's 3 to the second. That's going to be 9. So it's going to just start really taking off once we get to 0. It's going to just travel along that asymptote because what's happening is like x to the negative, let's say 10, would be 3 to the negative 10, which is 1 over 3 to the 10, which is just going to be a very, very, very small number. So that's just going to keep on going towards negative infinity out this way. So as we come over this way, x to the 0 is 1, x to the first is 3, x to the second is 9, and then just goes off. So boom, there's 3 to the x. Now from here, we are going to use what we know here and shift it, understanding these shifts. So we have 3 to the x plus 1. Let's first make sure we know what that implies. So the x plus 1, the plus 1, you want to ask yourself, is that in or out of the function? Because if it's in the function, then we have a horizontal shift. If it's outside of the function, then we have a vertical shift. And what I mean by in or out of the function is if I had like the function x squared plus 1, or let's just call it the x squared plus 1. This plus 1 is outside of the function x squared compared to x plus 1 squared. That plus 1 now is inside of the function. So in our example of 3 to the x plus 1, if I'm comparing that to, let's say, 3 to the x plus 1 like this, or 3 to the x plus 1, and those two examples I just wrote down, which one is inside of the function? The 3 to the x plus 1, like this one. That x plus 1 is inside the function. So now I've identified that the x plus 1 is inside the function. What does that mean? That means it is a horizontal shift to the left. Remember, inside of the function is always kind of like opposite. You might think logically like, oh, x plus 1, it's a horizontal, so I'm going to move to the right. But with horizontal, it actually shifts it to the left. So for every x value, it's going to shift over to the left 1. So everything is moving over 1 units this way. Oh, here. So this x to the, when x equal to 0 was 1, that's just going to shift over to here. And I'll show you how to like check your work here in a second. But we also have this other shifting going on of minus 1. So what does the minus 1 mean? That is outside of the function. Same, I was just showing you those examples of x squared plus 1 compared to x plus 1 squared, inside or out. Here, the plus 1 is out of the x squared function. So minus 1, that is going to be a vertical shift. So here was horizontal. Here is going to be vertical. That's minus 1, so that's going to be down 1 unit. So we're going to shift everything down 1 unit. So here's an easy way to do this. Since everything is moving down a unit, and I know the x-axis right here was a asymptote, so my asymptote now is just going to shift down. So it's going to be doing this. So my asymptote is going to be traveling along here, but once we get a little bit closer, here's where we got to make sure we understand what does that actually mean then. So everything's shifting down. So this is going to go down. And then we're also shifting to the left. So this is now going to hit here. This point is shifting down to the left. So now it's going to hit right here. And then this one is shifting down to the left, or left down, however you want to think about it. So it's going to hit right about there. So we're going to have, I lost my point. Down, down, down right here. Sorry about there. I kind of missed my point, but that's okay. So that is what our shifting, our 3 to the x plus 1 minus 1 is going to look like with that shifting. Our asymptote is going to come down 1 unit, and then we're just moving everything down a unit and to the left. So check your work though. Like, just, it wouldn't hurt to just like say, all right, well, what happens at x equals, let's say, -1. So that's going to be 3 to the -1 plus 1 minus 1. 3 to the -1 plus 1 is 0. Anything to the 0 power is 1. 1 minus 1 is 0. So at x equal to -1, we get 0. Yep, yes we do. And then just, let's just try out 0 just for the fun of it. So 3 to the 0 plus 1 minus 1. 0 plus 1 is 1, so 3 to the 1 minus 1. So that's going to be 3 minus 1 is 2. So at x equal to 0, right here, we get 2. Yes, we do. All right, cool. So I know this is a little bit of a roundabout way. You could just take x values from the start, like just take x equal to -1, or x equal to -2, x equal to 0, x equal to 1, x equal to 2. You could do that. That's perfectly fine. But we wanted to use the transformations and understand how the shifting works regarding horizontal or vertical. So I hope that was the whole goal, and I hope that helps with. I hope this video helps with that, being able to use the transformations, not just necessarily taking ordered pairs and plugging them in.